Let's talk about introduction part 2. We will be starting off with standard deviation. Okay, this is the format. Okay, suppose you're having n number of readings. Okay, x1, x2, x3, x4. You're having n number of readings. You find out their average, and then the deviations are as follows. Okay, your first deviation will be the second deviation, so you will have n number of deviations. Now you are trying to find out the average deviation, which is given by this formula. Now your standard deviation will be equal to this particular formula over here for values less than or equal to 20. Okay, but for values greater than 20 you are having this particular formula, so you have both of these formulas. Then we have variance, which is equals to square of standard deviation. Now suppose you are having n number of readings with n number of standard deviations, then the total standard deviation of these n number of readings is given by this formula. Okay, then we have error at desired scale. This is given by this particular formula, full scale error into full scale value upon desired value. Okay, now if your desired value is close to full scale value, then your error is minimizing. Let's talk about errors. Okay, the difference between measured value and true value is actually called the error. There are three types of errors: gross errors, systematic errors, and random errors. Gross errors are mostly due to human beings and are avoidable in nature. Suppose some mistake happen in taking the reading or while calculating and stuff, etc. So these come under the category of gross errors. Then we have systematic errors. These are due to instruments or the environment in which the instrument is kept. Okay, and then we have random errors. Okay, we are not sure about what are the reasons, but still we may experience some errors. Okay, so this is called random error. Let's talk about unit absolute dimension. Okay, we are having unit is the unit in which you measure something, and absolute and dimensions, which are pretty basic things. Okay, then we have analog instruments, indicating, recording, integrating, and null type instruments. In indicating type instruments we have both electromechanical and electronic types. Okay, and these instruments can measure current, power, frequency, voltage, energy, and power factor. The principle of operations utilized over here are magnetic effect, electrostatic effect, Hall effect, heating or thermal effect, electromagnetic effect. Okay, let's talk about electromagnetic effect. Current carrying conductor placed in magnetic field could experience attractive or repulsive forces, leading to principle utilized as attraction type moving iron type instrument or repulsive type moving iron type instrument. Okay, then we have heating or thermal. Current through small element causes temperature rise, and EMF is generated by the thermocouple. Examples are a meter, wattmeter, and voltmeter. Electrostatic effect, you pretty much know the electrostatic force of attraction, okay, or repulsion, and this is used in electrostatic voltmeter. Then we have electromagnetic effect used in voltmeter, meter, or wattmeters. Then we have Hall effect. Semiconductor carrying current placed in transverse magnetic field leads to EMF at both ends of semiconductor perpendicular to both B and the current. Okay, so this is all for part 2, and in part 3 we shall be covering these two topics.